So welcome to this little episode that I put together. I did one yesterday and I'm following it up today. The one yesterday was talking about using high school math in the house build that I'm doing. And it was entitled House or High School Math, Really? This time it's going to be a similar title. We're going to go in some different things. Yesterday we used Pythagorean theorem and we used sines and cosines predominantly to be able to do things. But this time we're going to talk about areas, circumferences, perimeters, volumes, surface areas in particular, in doing some things. And I won't take you through all the calculations, but I'll give you some examples of those. This channel is basically just to update with the build of our home, primarily for friends and family. Hope you enjoyed if you happen to stumble across it and look at what we're doing. This is the second one that's not really a status of the house itself so much, but things that we've gone through in the build because we've got the foundation poured and it's in the middle of curing right now. So what I'm going to do here very quickly is just show you again the overall kind of floor plan or foundation plan of the house, and then we'll reutilize this or pieces of it as we go through the rest of the video today. The first thing that I want to throw up is to give you an idea of the actual things that we'll use from kind of geometry today. We'll even deal with some things with fractions because we'll have half circles, half spheres, half cylinders, quarter cylinders, things like that. So some of the formulas we have are for the full thing, but then we'll use the fractions to divide it into the size of what we really need it to be. What I'm showing now are the main geometric figures or shapes that we're going to use. We'll have a a circle where we'll have the area. I do use the circumference in some of the calculations that we do. Won't go through those particularly today, but certainly some of the areas. Again, kind of rectangular shapes or squares, those kinds of things, mainly rectangles, but we'll do with the area, not so much the perimeter, but we do sometimes have a little bit of perimeter calculation. And then from a 3D, where we're really getting in away from areas a little bit and into volumes, we've got a sphere, we've got a kind of a rectangular cube. It's a cube, but not all the sides will be equal. There'll be different sizes. And then we'll also do a cylinder. When we're looking at these, we're mainly looking at the volume that we're looking at for some of the calculations that we need to do. And we're looking at some of the surface areas involved with those 3D shapes. Now, a little bit of the background before we get into some of what we're actually doing with the house is a couple of examples. One of the things that I had to do when I went to get the permitting at the building department was, we had to produce several documents, floor plans, site plans, subcontractor list, which you can build as you're going through. But one of the things I had to put together was at least an initial material list, even though it wasn't perfect. So some of these calculations supported me being able to do that, like figure out the amount of concrete needed in some cases, ceiling paint that was needed in cases. We'll use those in particular, paints for wall surface areas. There were other things about length of pipes, blah, 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 blah. We went through the whole material list. So these are going to be the things that we'll be doing with these shapes and using these formulas that I've just shown you today. The first one of the items that we'll go through is as an example, is calculating the footings for the foundation effectively that we needed to do. As you'd seen in the floor plans, we have some things that are based on radiuses. We have things that are based on, basically rectangular shapes or straight line type shapes instead of circles. And so what I'm going to do first is take you through calculations of the footings for the radial. And these are all based off of circles because they're got radius involved with them. So to get the concrete, we're first going to go with the area, and then we'll end up computing the volume. But to be able to do that, we've got to at least get the area that we really have to deal with in these radiuses. You can see in the upper right hand, we've got some pictures of the footing, and they're basically 18 inches deep, which we'll come back to, and 24 inches wide. And we can't compute directly from the 24 inches wide, but we will use the 18 inches deep. So what you see in the center is kind of snippets from the foundation plan. So we've got like what's over on the left end of the house, main house. There's also a similar shape on the right end of the main house. We've got a larger but similar shape out in the garage, and we've also got a smaller one for the pantry. And so I just give you some ideas of, what we did here. So with the main house, what's there kind of on the left, not facing at an angle, your inside radius for the footing is off of the vertices that I talked about in the episode yesterday, 11 foot 6 inches, and then the outside radius is 13 feet 6 inches. So there you get the 2 feet delta that we were talking about earlier. So the area of the footing is really only a half circle. But what we need to be able to do is only cut that or calculate that 2 foot wide sliver that's there. So the way that we do that is we calculate effectively the area of the inner radius using it, and then we calculate the same kind of area for the outside radius, and we subtract the calculation from the inside radius from the outside radius. That gives us the area that's only that 2 foot sliver that's going through there. And then again, to end up changing that into a volume and making that a volume, we basically multiply by the 18 inches or 1 foot and 6 inches. When we go in the pantry, the inside radius is 5 foot 1 inch, the outside 7 foot 1 inch. So we substitute those numbers in for the radiuses to do the same calculation. And with the garage, the inside radius is 16 feet 7 inches and the outside is 18 feet 7 inches. And so from that, you can calculate the volume in square feet, or well, cubic feet when we get to the volume, of how much concrete it's going to take. And then you really need to convert that into yards. So there's 27 cubic feet within a cubic yard. And that's what you're ordering when you order concrete. So you can divide your totals that you're getting for this through by 27, and then that gives you how many cubic yards of concrete that you need. The second part of the footing calculation are all basically rectangles. So you look at the links and you read the links that are off of the diagrams. I've highlighted them in the diagram that you see in the blue. Here we calculate initially the area, which is the length times the width. The width's going to be 2 feet in this case. The length is whatever it has. Some of them are 6 feet. Some of them are longer than that. Some of them are, 24, 49 feet 10 inches, or 49 feet 8 inches. So there's various ones that we have. So what we do is we multiply the length times the 2 feet, which is the width, and then we multiply by the 1 foot 6 inches, and then that gives us the volume. And again, to go to yards for the concrete needed for those footings, then we divide through by 27 because we've calculated cubic feet and we need to convert that to cubic yards. So that's the second phase of that part of it. The second overall example that I want to talk to you about, and we've got a couple of diagrams here for this. So what we're doing is the slab calculations. Here again, we're going to use circles, we're going to use rectangular areas. To be able to get volumes for some of this, we'll use cylinders and cubes to get the volume aspect of it if you want to go through the, well, we do have to go through those. In this case, the height, where in the footings and the foundation, we had an 18-inch depth, foot 6 inches. Slab's only 4 inches, so it's only a third of a foot, basically. And so that becomes our height that we're going to have. So what we've got is that if you want to know what the cylinder volume is for the radial ones, you can use the radiuses. We use the inside radiuses this time only, which we showed in the footing foundation calculation. So that's where we get the radial entries for the 4 radiuses that we have. And you can either compute the area of the circle by doing pi r squared and then multiplying by the 1/3 foot, which then gives you the volume. So you're basically doing it that way either way. I've given both formulas here, so you can do that. And then in the others, we create the rectangles. We get the lengths and the widths off of the diagram. We can compute those, and then again, to go from area to volume, we multiply by the 1/3 foot for the 4 inches. And we add all of those things up, and the summation gives us the total. To go to cubic yards, again, we divide through by 27. So here again, we're beginning to use those, and I'm showing you too on this some of the measurements that go into some of these as we go through that. So that's the slab calculation, sort of the third thing that I wanted to be able to show you, and we're going to move on to the next one. The final example I'm going to give you, because it gets into particularly cylinders and spheres, in this case, is calculating ceiling paint for this thing. So what we're looking at really here, instead of doing volumes like we've dealt with in the previous calculations, we're going to be dealing with surface areas. So we're going to be looking at primarily like quarter sphere surface areas. We're going to be looking at half cylinders and quarter cylinders when we're doing some of those that are in there. So again, I've sort of marked this up a little bit. I'm going to show you 2 different pictures of sort of the same thing of where the calculations are coming from. So I've got one that's the main house, and you'll see that I have a little diagram in the bottom right corner for it that shows that we got basically a kind of a 12-foot radius for the steel that creates part of the structure that goes over. Those create the cylinders, and it creates the radius for that. But we're going to be about 3.5 inches back from that. So like the radius is really going to be 12 feet, 3.5 inches for most of the main house stuff that we're going to do. For a sphere, the surface area is 4 pi with the radius squared. And then the surface area for a cylinder is pi r squared times the height or the length, however you want to call it. So what you see is the dark blues, our spherical calculations that we have there, and then the cylinders are basically the ones where I've got them in the medium blue or the lighter shade of blue. And so what I've put on here for these is I show you the radiuses for most of these. I also show you what the height would be or the length would be, so that you can compute. And then, of course, if you're using the formula for like the sphere, 4 pi r2 or r squared is the calculation for full sphere, the surface area of full sphere. Well, we're only going to have a quarter of that. So you divide it by a quarter, which means you're really only doing pi r squared, which is a similar area to just a 2-dimensional circle. Now, with the cylinders, we've got 1/2 for some in the barrel sections, I'll call them, and then quarter on a couple of places that we have to worry about. And so what we do there is, again, you use the pi r squared h, but for a half, you just divide it by 1/2 And for a quarter, you just divide that calculation by a quarter. And I've given you the radiuses and the heights again in here. And this one's for the main house. The next one and the last example, and it's more difficult, so I don't go into it so much, but I wanted you to realize that, and I throw it up, and you've got a similar diagram, except now I've got the garage workshop area shown, and what you can see is there's different vertices points involved with it. And so what happens is that you actually change the radial, so you're actually doing smaller chunks and have to break it up more and then sum those pieces together when you're doing the spheres and when you're doing the barrels on this one. Now, one of the things, and I didn't really call this out when I was talking about the last one, but what you'll see is to be able to have code and to have your electrical receptacles vertical, like you'd have in a normal stick frame house, which this one's not. It's steel and shotcrete for the walls. You actually have 2-foot sections that are vertical on these things. So you've also got to use sort of rectangles. You've got a length, you've got a height of 2 feet. You measure those things off, and that'll give you the surface area for that portion of the barrel or that portion of the sphere itself. And so you sum those pieces in and add those on to the calculations that you've done to get the full total of all the surface areas of everything that you've got in these barrel sections and in these radial and spherical sections. So that's examples of how we're using high school math. And this is, this is just to give you an example, not to take you through everything that I did, but to give you an idea how, even here in retirement again, I find myself going back to high school, and even when we talk fractions, sort of going back to grade school mathematics and stuff that we're doing in this. Thanks for putting up for me going through this, both yesterday for the initial high school math, really, and then today with the high school math, really, the sequel. I'm not going to go through another one of these, but, like I said, what I'm trying to do is just update people on the status of the house. We have a little bit of a break right now, and I thought it might be kind of just fun thing to go through this, because sometimes people say, well, when am I, if they're going through high school, you hear the teenagers, when am I ever going to use this in real life? Well, here's an example. Me in retirement, I'm still using this stuff. So thanks for watching. Hope you enjoyed it.